All right, let's go. Number 10, the fate of the cosmos, also known as the Big Rip. Buckle up, it's a wild ride. When you gaze at the night sky on a clear evening, everything looks peaceful, static, and eternal. But looks can be deceiving.
The stars seem locked in their constellations, and the Milky Way feels like a permanent fixture of our reality. It's a cosmic illusion. The universe isn't a static stage. It's a dynamic, evolving entity racing toward intense conclusion. Physics doesn't lie, folks.
This ultimate fate is the Big Rip. It's driven by the relentless, accelerating expansion of space itself.
To understand this, we must look deep into the future, far beyond our sun's lifespan and the dramatic moment of the last stars. We're heading to a time when the very fabric of reality begins to tear. It's the ultimate cosmic breakdown. Can you imagine?
Currently, gravity is strong enough to hold our solar system and the Milky Way together. But for how much longer?
Gravity holds our solar system to the sun,
and the Milky Way to its neighbors.
It's a cosmic anchor, for now. But space itself is stretching. Worse yet, it's accelerating, pushed by a mysterious, invisible force we call dark energy. In the Big Rip, dark energy doesn't just push. Its power grows relentlessly, eventually threatening to tear everything apart. It will overpower every force in nature. This cosmic dismantling is a chilling, precise countdown to the end of reality. Billions of years from now, expansion connect impossible speeds. The night sky will slowly fade into a deep, eternal black. Galaxies will race away faster than light. Their glow will vanish forever, leaving us isolated in an ever-shrinking observable universe. Even our closest galactic neighbors will be ripped away. Gravity's grip fails as the void between them expands uncontrollably. It doesn't stop there. This phantom energy keeps growing, finally shredding the Milky Way itself into a scattered mist of stars. The Milky Way's stars scatter into the void, leaving our solar system isolated in a profound, unimaginable darkness. Months before the end, even the sun's mighty grip fails. Gravity can no longer hold the planets in their ancient orbits.
Our Earth is stripped away, flung like a pebble into the freezing, silent emptiness of deep space. We are truly alone.
In the final hours, Earth shatters. The expansion of space overpowers the very forces holding our world's core together. Everything breaks. It's left. Every mountain, every ocean, and every human artifact is reduced to scattered dust. Our entire history becomes cosmic debris. In the final fraction of a second, atoms fail. Molecules are torn apart as the fundamental forces of nature simply give up. Atoms rip into protons and electrons. Then, even those subatomic particles are shredded into absolute nothingness. The building blocks are gone. Finally, the fabric of space and time itself tears apart, leaving nothing behind. This is the Big Rip. Absolute silent finality. Number 9. Accelerating expansion of the universe. To understand this apocalypse, we must travel back to a pivotal moment in our past.
For most of the 20th century, the story was simple. The universe was born in the Big Bang and has been expanding. The critical question for cosmologists was how this expansion would end. The assumption was based entirely on the force of gravity.
Since all matter exerts a gravitational pull, it was believed this collective gravity acted as a cosmic brake, slowing everything down.
Scientists believed they lived in a slowing cosmos. Their task was to measure that deceleration to see if it would ever stop. Would it collapse in a big crunch or just expand forever, coasting to a slow, freezing halt? The answer seemed...
In the late 1990s, two independent teams set out to measure this slowdown. Their method was ingenious. They used Type Ia supernovae. These specific supernovae are cosmic standard candles. By measuring their brightness, astronomers can calculate exactly how far away they are.
Back in the late 90s, two rival teams of astronomers raced to measure the cosmic slowdown. They bet everything on gravity winning. Their secret tool? Type Ia supernovae. These are the spectacular. Because every Type Ia supernova pops with the exact same power, they act like cosmic light bulbs of known wattage, pure scientific gold. By gauging how faint these flashes look from our tiny planet, we can map out the vast distances of the deep cosmos. By seeing how much that light has been stretched, or redshifted, we can clock exactly how fast the universe was growing. They peered into the darkest corners of the void,
hunting for the ghostly flickers of stars that fall eons ago. When the numbers finally crunched, the scientific world stood still.
Oh.
The data didn't just surprise them, it broke every rule we knew. The supernovae were way too dim. They were much further away than expected, revealing a universe that's actually racing apart.
This meant they were much further away than they should have been. The universe was not just expanding, it was actively speeding up.
Imagine throwing an apple straight up into the air. You expect Earth's gravity to slow its ascent, eventually making it fall back down. Now imagine throwing that apple, but instead of slowing, it suddenly accelerates.
That is exactly what the universe was doing. It defied all known logic and shattered the prevailing cosmological models. This discovery proved that the universe was not a closed system, governed simply by the gravity of stars and galaxies. Something massive, unseen, and incredibly powerful, steering the entire cosmos toward an entirely new destiny.
The realization that the expansion of the universe was accelerating left physicists with a massive, glaring problem. Acceleration requires energy. A car does not speed up on the highway without someone pressing the gas pedal.
Imagine throwing an apple straight up. You'd expect gravity to slow it down, right? But the universe had other plans. Instead of falling back, that apple suddenly ignites, launch faster and faster into the sky, like a hidden rocket. That's exactly what our universe is doing. It's defying every known law of logic and shattering our old models.
Something massive and unseen is steering the entire cosmos toward a brand new destiny. We call it dark energy. This discovery left physicists with a massive problem. Acceleration needs energy, and we had no idea where it came from.
Think of it like a car. It doesn't just speed up on its own without someone flooring the gas pedal. Ah, I get it.
The universe is that car, and dark energy is the monumental force pushing the pedal to the metal.
But here's the kicker. Dark energy isn't just dark. It's completely invisible, transparent, and interacts with absolutely nothing.
Scientists are scratching their heads. Dark energy is 68% of everything, yet it's a total mystery to us. Oh, yeah, definitely a mystery.
Enter Albert Einstein. He originally added a cosmological constant to his equations to keep the universe steady. He opposed the idea of a changing cosmos. But when expansion was proven, he called it his greatest blunder.
He tossed it out. Fast forward to today, and that blunder is back to explain our accelerating universe.
Now we think dark energy is just a property of space. Space isn't empty. It's a living, breathing medium. Astronomers aimed their massive telescopes at the void, hunting for the ghostly, faint flickers of stars falling billions of years ago. Fascinating.
When the data finally arrived, it connected the scientific world like a thunderbolt. The results were utterly, beautifully impossible.
Those supernovae were far dimmer than predicted. It meant they were drifting much further away than anyone ever imagined.
The universe wasn't just growing, it was racing. The expansion was actively accelerating into a deep, cosmic mystery.
Think about tossing an apple into the air. You'd expect gravity to grab it, slow it down, and pull it back. But instead, the apple suddenly ignites, blasting faster and faster into the heavens, driven by a mysterious, invisible rocket force. That's the universe for you. It defied every rule of logic and completely shattered our old models of the cosmos.
This proved the universe isn't just a simple machine. Something else is out there, steering us toward a new destiny.
The universe isn't just expanding, it's speeding up. This discovery shattered everything we thought we knew about gravity.
In the late 90s, astronomers found that distant supernovae were much dimmer than expected. The cosmic brakes were actually a gas pedal.
Imagine throwing an apple up. Instead of falling back down, it rockets away faster and faster. That's our universe right now.
We call this force dark energy. It might be a fundamental property of space itself, pushing everything apart.
But there's a catch. Quantum physics predicts an energy density that's off by 120 orders of magnitude. It's a total disaster. Then there's dark matter. The projectile's cluster collision proved it's a real substance, not just a math error. When clusters collide, the hot gas powerful impact together, but the dark matter ghosts right through, leaving the gas behind. This separation is the smoking device. Dark matter is a tangible, invisible glue holding the entire cosmos together.
The projectiles cluster is the ultimate proof. Dark matter isn't just a math error. It's a real, tangible substance unlike anything we know. But how do we track a ghost? We use Einstein's genius. His general theory of relativity reveals the invisible through the warping of space. Einstein showed that mass warps the fabric of reality itself. To visualize this cosmic bending, let's look at a simple trampoline analogy.
Picture a heavy bowling ball on a trampoline. It creates a deep dip, right? That's exactly what massive objects do to space-time.
Roll a marble nearby, and it spirals in. In space, massive galaxy clusters are the bowling balls, and light is the marble. Light must follow these cosmic curves. This creates wild optical illusions, making distant galaxies look stretched, smeared, or
sometimes light bends into a perfect glowing halo. We call this an Einstein ring, a beautiful signature of gravity's power over light. This is gravitational lensing. It occurs when invisible dark matter acts like a giant cosmic lens, magnifying and distorting the light behind it. Behold the projectiles cluster. Located 4 billion light-years away, it's the ultimate cosmic laboratory for testing the existence of dark matter. Galaxy clusters are made of 3 things: visible galaxies, clouds of hot gas, and a massive, invisible halo of dark matter. When 2 of these giants collided at millions of miles per hour, the components behaved in ways that changed physics forever.
The galaxies slipped past each other like ghosts, while the hot gas powerful impact together, creating a massive But the dark matter? It sailed straight through the collision without slowing down, completely ignoring the friction that stopped the gas.
This separation of visible gas from invisible mass was a watershed moment. It provided the smoking device evidence we needed.
By mapping the gravity, astronomers saw the mass was far from the gas. Dark matter had detached and kept moving. The projectiles cluster proved it. Dark matter isn't just a math error. It's a tangible, physical substance distinct from normal atoms. How do we map the invisible? Einstein's general relativity gives us the key. Massive objects warp the very fabric of space-time. Think of a heavy bowling ball on a trampoline. It creates a dip that forces anything rolling past to curve inward.
Light follows these cosmic contours. When dark matter sits in the way, it acts like a giant, invisible funhouse mirror.
This is gravitational lensing. It produces Einstein rings, stunning, perfect circles of light from galaxies billions of light-years away.
By measuring the angle of this bent light, we can calculate exactly how much invisible mass is lurking in the dark.
Usually, outer objects orbit slower. But these stars defied physics, refusing to fly off into the void as they should.
The only explanation? Every galaxy is anchored by a massive, invisible dark matter halo that provides the necessary gravitational glue.
Vera Rubin proved every galaxy is haunted by an invisible ghost, far larger and heavier than the galaxy itself.
This brings us to the missing mass problem. While Rubin made it undeniable, she wasn't the first to find this ghost.
Her work in the 70s forced a consensus, but the mystery's true origin dates back to the 1930s and Fritz Zwicky.
Zwicky wasn't looking at single stars. He was studying the Coma cluster, a massive collection of over 1,000 galaxies.
He wanted to find the total mass of this cluster. To do it, he used 2 very different scientific methods.
First, Zwicky tried the classic approach. He measured the total light pouring out from every single galaxy in the cluster,
estimating the number of stars needed for that glow, and tallying up the total mass of all that visible matter.
Next, he analyzed the cluster's internal physics. You see, the Coma cluster isn't static. It's a violently active arena,
where galaxies swarm around one another at breakneck speeds, just like a chaotic hive of angry, buzzing bees.
Zwicky tracked these velocities to figure out the exact gravitational pull required to prevent them from simply flying apart
and vanishing into the void. But when he compared his 2 results, the difference was absolutely mind-blowing. The mass needed to anchor those speeding galaxies was far beyond anything he could actually see in his telescope. It was roughly 400 times greater than
than the mass of every glowing star in the entire cluster.
All that visible stuff? Stars, gas, dust? I mean, it's barely a tiny fraction of what's actually lurking out there.
In 1933, he named it Dunkle Materie. That's German for dark matter, folks. He dropped the missing mass problem right on the scientific community's doorstep.
But get this, the world basically ignored Zwicky's massive discovery for nearly 40 years.
The idea of an invisible universe seemed way too crazy and radical for scientists back then. Maybe it was just too intense to accept that we can't see most of reality.
It was tossed aside as a weird math glitch, just a tiny footnote in history.
But in the 70s, Vera Rubin forced us to look again. She wasn't looking at clusters, but individual galaxies. She focused on Andromeda, our neighbor. She asked a simple question: how fast do these stars actually spin?
In our solar system, inner planets race while outer ones crawl. It's basic physics. Distance equals slower orbits.
But Andromeda broke the rules. The outer stars were falling out along just as fast as the inner ones.
Newton's laws said they should fly off into the void. Yet, they stayed. Something invisible was holding them. This ghost isn't just in galaxies. It's etched into the very first light, the cosmic microwave background.
This is the universe's tiny figure picture from when it was just 380,000 years old. A faint microwave glow. It's not smooth, it's a detailed map of tiny temperature ripples. These are the seeds of everything we see. Amazing, we're seeing the beginning of it all. Dark matter is immune to radiation pressure. It doesn't care about light. It just clumps together, building the universe's skeleton. Right after the Big Bang, it formed massive gravitational sinkholes. It was the invisible scaffolding while normal matter was still trapped.
When the universe cooled, normal matter finally fell into these pre-made wells. Without dark matter, we'd just be a thin, scattered mist.
So, what is it? For decades, the top candidate was the WIMP, a heavy, slow-moving particle born in the Big Bang's fire.
Millions of them could be passing through your body right now. You wouldn't feel a thing. They're like cosmic ghosts.
We built massive detectors deep underground, shielded by miles of rock. We're waiting for one single WIMP to bump into an atom. Decades of waiting, billions of dollars, and nothing. The WIMPs are staying hidden. It's the greatest detective story in modern science.
What if we're looking for something that isn't there? What if dark matter is an illusion, a misunderstanding of gravity itself?
The universe is dominated by an invisible mass. But this wasn't discovered through massive cosmic collisions.
No, the first real proof came from observing our own galactic neighborhood, studying the mechanics of individual galaxies up close.
In the 1970s, astronomer Vera Rubin meticulously observed the Andromeda Galaxy, our closest galactic neighbor.
Her focus was simple. How fast do stars in a spiral galaxy truly move?
To grasp her discovery, let's first examine our own solar system's mechanics. Planets near the Sun, like Mercury and Venus, orbit incredibly fast, deep within its gravitational pull.
Further planets, like Neptune and Uranus, move much slower. It's a basic law. Distance from mass dictates orbital speed. Astronomers assumed galaxies followed this rule. Visible mass concentrated centrally, dictating orbital speed.
She assumed they'd play by the rules of our solar system, where distance from the center determines your speed.
Close to the Sun, planets are speed-dark creature. But way out by Neptune, things get a lot more sluggish. It's the golden rule of gravity. The further out you go, the slower you should be orbiting. Simple, right?
Except Andromeda didn't care about the rules. Rubin found stars at the edge racing as fast as those at the core.
He was eyeing the Coma Cluster, a swarm of 1,000 galaxies zipping around like a hive of angry bees.
His math call out that there wasn't nearly enough visible stuff to keep those galaxies from flying apart into the void. Zwicky wasn't just peering at a single star. He was hunting the Coma Cluster, a colossal swarm of over 1,000 galaxies.
He attempted to weigh this cosmic behemoth using two distinct methods. But the results? They didn't just meet, they were utterly impossible. First, he tallied the light. More glow means more stars, right? He calculated the mass based solely on what he could see. Then, he clocked their speed. Those galaxies were buzzing like frantic bees in a hive, moving way too fast for their weight.
To prevent them from scattering, Zwicky realized there must be 400 times more mass than the visible stars could provide.
He dubbed it Dunkel Materie, dark matter, a ghostly invisible anchor holding the cluster together. Doesn't make sense, but the scientific world just wasn't ready.
The establishment scoffed. They dismissed it as a math error, a glitch, an absurdity.
Zwicky's genius was relegated to a dusty footnote.
For 4 long decades, his discovery gathered dust. Intense truth hidden in plain sight, waiting for science to finally catch up.
Vera Rubin wasn't looking for ghosts. She was just measuring how fast stars spin around the Andromeda galaxy. She expected outer stars to move slower. Instead, they were racing at impossible speeds, defying the known laws of physics. Galaxies only stay together if they're anchored by a massive, invisible halo. Every galaxy is haunted by a dark matter ghost.
These tiny temperature ripples are the seeds of reality. They show us exactly where the first structures began to grow.
Dark matter built the invisible scaffolding of the cosmos. Without it, normal matter would be just a thin, scattered mist. We see its shadow, we feel its pull, but we still don't know what it is. The greatest detective story continues.
If it's not normal atoms, what is it? Physicists are hunting for a ghost particle that changes everything.
The top suspect? WIMPs, weakly interacting massive particles. They're heavy, slow, and passing through you right now.
To catch one, we've gone deep underground. Miles of rock to block out the noise of the universe. We've waited decades, spent billions, but the WIMPs are staying silent. Is our best theory just
wrong? Maybe we're looking for something that doesn't exist. What if dark matter is just a cosmic illusion?
Enter MOND. It says we don't need new matter, we need new laws of gravity.
Sorry, Einstein.
MOND explains the spin, but fails the big tests. We're stuck between a ghost and a broken law. MOND is a math wizard for galaxy spins, but it connects a wall when facing the projectiles cluster's massive lensing. It also can't explain the temperature maps of the Big Bang's afterglow. The math is elegant, but the universe is messy.
We're at a cosmic crossroads. Most scientists bet on dark matter, waiting for our tech to finally catch this ghost.
Either we're surrounded by an invisible ocean of matter, or our fundamental rules of gravity are just plain wrong. Our journey through the stars is a humbling reminder of our tiny place in this grand, dark design.
We are fleeting observers on a pale blue dot, staring into an abyss ruled by forces we can't even see.
Yet, the fact that we can measure these shadows and calculate the end of reality is a testament to human curiosity.
We may never touch the phantom energy stretching the void, but our search connects us to the very fabric of existence.
The universe may be dark, impossibly vast, and destined to eventually tear itself apart in an intense rip.
It is a cold, lonely future, dictated by forces we are only just beginning to name.
But for this brief, beautiful cosmic moment, something extraordinary has happened.
It has produced a species brave enough to look up from their tiny world, to stare directly into the intense abyss of the unknown. To 10, and demand to know why it all exists.
Our curiosity is the light that illuminates the shadows of the dark universe. The flashlight beam cuts. We are the cosmos seeking to understand itself. And that is the greatest journey of all.
She found stars at the galaxy's outer edges weren't slowing down. They maintained high speeds, defying all known physics. These distant stars orbited at the same high velocities as those near the core. This was a cosmic anomaly.
By Newtonian physics, this was simply impossible. The galaxy should have torn itself apart. At such speeds, outer stars should have escaped the galaxy's pull, flung into deep space like water from a spinning tire. Yet, they remained. The galaxy should have ripped itself apart. But it didn't. It held together, defying all logic.
Stars remained in stable orbits. The only explanation? Our visible galaxy is just a tiny fraction of its true massive size.
Rubin proved every galaxy is engulfed in a massive, invisible halo of dark matter. This ghost provides the gravitational glue, far larger than the visible galaxy. This invisible halo is the cosmic glue holding everything together. Every galaxy is haunted by a massive, unseen ghost.
Zwicky wasn't just looking at one galaxy. He was studying the Coma cluster, a massive group of over 1,000 galaxies. He used two methods to weigh this cluster. First, he counted the light from all the visible stars.
Then, he measured how fast the galaxies were buzzing around each other. The results were absolutely shocking.
The gravity needed to hold them together was 400 times greater than the visible mass could provide.
Poor Zwicky. His dark matter was tossed into the scientific trash bin for 40 years. An invisible universe? Simply too crazy to believe. But look closer at the oldest light in existence. This cosmic tiny figure picture proves that something invisible was pulling the strings from day one. Dark matter is the universe's hidden skeleton. Without this ghostly scaffolding, we'd all just be a thin, boring mist floating in nothingness. So, what is it? We've buried massive detectors miles underground, holding our breath for a single ghostly particle. Decades of silence are making us desperate. Are we hunting axions, tiny black holes, or something so weird we haven't even named it yet?
Or maybe gravity is just lying to us. MOND says we don't need dark matter if we're brave enough to rewrite Newton's rules.
Ghost particles or broken laws? Either way, our obsession with these cosmic secrets is what truly weaves us into the fabric of reality. We're just tiny specks on a pale blue dot, yet we're bold enough to stare into the infinite abyss and demand an answer.